So just to begin, with anybody here from a security background? Is there anybody here who, okay, security? Well, you don't count. You just anybody else from the security? Probably, maybe not, right? Yeah. So how many people? Not many people from security, but how many people in the room would agree that APIs, probably when it comes to things like security testing, probably are either misunderstood or not given the respect that they're due? Would people agree to that? Yeah. So this is like a therapy group for API developers and architects and what have you, that we're going to talk about building an API security program. One size does not fit all, but I hope that today when you walk away from all this, you'll get an idea of taking some of the slides, some of the concepts and ideas, and maybe bringing it back to your organization and transposing that in some way back into your area. Now this class I like to do is a little interactive. I'm a survivor of law school where everything is Socratic Method, where you're sitting there on the edge of your seat. We're not going to do that today. But do we have any lawyers in the audience today? Can I have a good lawyer joke? If people have a good lawyer joke. What the difference between a good lawyer and a great lawyer? A good lawyer knows the law. A great lawyer knows the judge. Okay, so. We're going to continue on, but if any way part along the way, I might just ask for a show of hands and maybe a little interactive, mild Socratic Method, mild. Anybody here been to API Strat last year in Boston? There was an English gentleman that was there who raised bees, and I can't remember his name, but he talked about the idea of sitting at a table and working with people next to you and trying to describe what an API is, right? Turn to the person next to you for 30 seconds, try this at your next staff meeting, right? You'd be very surprised at the answer you'll get. Maybe take it a step further and ask, let's not just describe what an API is, but let's talk about API security, and then you'll totally confuse people, and they won't know what the heck you're talking about. Developers, any developers here? I'm a recovering developer. All right, the SDLC, as it's taught in school, the software development lifecycle. So for people who were taught, from 20 years on, or even farther back, right? There's a certain way you go about developing software. There's requirements, there's analysis, there's design, there's implementation, right? So we figure out requirements, we design the software, we start to write the code, we design it, then we implement it, we test it in maintenance, right? And it looks something like this, and it just keeps going around and around and around. Now, in a DevOps world, that's something that's just happening from the time they commit the code now, all the way through like an hour or 2 hours. This is still going on somewhat, but at a very rapid pace, And this is where you really have to get the analysis correct. But my question is, what about security, and specifically API security? When you went to the course, we learned about software development. Was security ever mentioned? No, never mentioned. Right, you're absolutely right. That was something that was just way off in the distance, right? Hacker this and that. People say, oh, come on, So we were far better today at understanding all the different things. I mean, just look at Equifax, right? What happened with Equifax? Everybody knows that, probably because over 50% of the people in this room were probably affected by it, if not more. So building an API security strategy, right? So you want to take a hold of that traditional SDLC and then modify it, because your developers do know what this means. When you speak SDLC to them, or at Aetna we call it the APLC, the Aetna Lifecycle. So this will all kind of make sense here in a few more slides, but this is going to be, if you picture a slide from left to right, this is going to be on the far left side. So this is your requirements phase for APIs, and this is what you do traditionally with the rest of your software, your web applications, mobile applications, desktop applications, even the old mainframe applications. They would sit down and talk about the requirements, right? Getting all the questions out front with groups, and how are we going to start to understand what it is we are going to build. So you see things, for example, API risk classification. I think most people would say that in their organization, if you sat down with a group and talked about it long enough, you'd get some consensus that, okay, we have one-to-many APIs, but they're not all equal. Some are more important than others. Some handle very sensitive data, confidential data, and some are more just publicly facing, and it's just something it's read only and it's not a big deal if somebody got that information. So you want to think about your API risk classification. How many APIs do we have? How do we risk rate them? How do we triage them into a one-to-many list? Because you're going to have to start somewhere. Someone asked me a question before the class, what happens if you're an existing organization and you're like, okay, this is cool, but we've already got APIs sitting out there. How do I start this thing? That's what you would want to do. You'd want to start with an API risk classification group and talk about, you're not going to be able to look at all of your APIs at once. Most likely, you're going to have to go after the most important ones first and just deal with it and move on as you go. Security requirement definitions, right? For example, down below, all API input must be validated. External versus internal APIs, that's a big one. How many people here have external and internal APIs, the externally facing versus internal, right? There's a difference. There's a difference, a big difference between what we're presenting to the world and what we're presenting to each other, right? That can help you triage and get your risk classification together for your internal APIs, and your organization knows it better than anybody else. Authentication and authorization. It's funny, if you mention API security, the software development guys and the software security guys will say, it has to be input validated, that's the most important thing. And then you get the guys in architecture and saying, no, it's authorization and authentication, but they're both right. They're both right. You want to have both groups in those discussions. So you want to have your architects. You want to have your software security developers. You want to have your project managers. You're going to have a really nice brainstorming session. And you want to kind of have it open where you don't want to sit there and say, oh, come on, that's a crazy idea. We would never do that. You want to keep it open and keep it open-minded because you never know what you're going to find out about your organization. The last person that walks in, you're like, who is that? All of a sudden they sit down and say, hey, we've got 3 externally facing APIs from about 10 years ago that we need to shore up, and I'm the only person that knows about it right now. So you never know what's going to be uncovered in a meeting. So just something to be concerned about and to be aware of. So now we've talked about the requirements phase. Now we're going to talk about the design phase, which is moving from left to right. So you've got requirements on the left, and now you've got design. Threat modeling. Does anybody here really understand threat modeling and understand what it means? I mean, we kind of know what it means. It's easy to talk about, but harder to do, right? Would you agree that's harder to do than it is to... Okay, but if you have somebody on your team, in your organization, who understands threat modeling and knows what they're doing, that's the person you want to have at this point in the process. Understanding the threats, the attack vectors, and the assets that you're protecting. This all leads to a secure API design. Okay? Moving on into the next phase. Now this is the slide that gets a lot of attention, and this is the one that will probably help you the most for your organization. If you bring something back and say, I may not understand what Mark was talking about, I may not understand what he was telling us, but I understand, I get it, this slide. This is the left to right requirements, design, deployment, test, and production, right? So at Aetna, we have our Secure SDLC, and we apply this to web and mobile and APIs and desktop. So we're a large organization. You have to make it work for a lot of moving parts. And again, maybe not everything in here would affect you or would be applicable to your organization, but I think quite a bit would. So we talked about the requirements phase on the left, design phase. That's the preventative area, and the last part of the preventative area is development, right? That's where we're actually writing code, where hands are on the code. Developers are saying, finally I get to do something. Enough of these meetings and charts, now I get to actually write some code and crank something out and start testing, right? All these things. Not so fast, not so fast. There are things within API security, building this API security program, as well as web and mobile, as all the other areas of software development that you want to be concerned about, meaning static analysis. Does anybody here know what static analysis means? Yes. So static analysis, I always say static analysis is when the developer's hands, when he or she have their hands on the keyboard, and they're using some kind of tool to run static code analysis on their code, looking for vulnerabilities when the code is being written, okay? As we'll discuss in a little bit, that's the point when you really, if you can't get it in the requirements and the design phase, that's the point where you really want to get it, is when the developer has her or her hands on the keyboard writing the code. It's far more efficient and far more cost effective for your organization to catch the code vulnerabilities, the bugs at that phase than it is when it's out in production. Open source analysis, right? What type of open source libraries are we using with in and around our API with this development? You know, are we using any? What are they? If they are using some, does anybody understand the security surrounding this? Is there an existing security vulnerability that's already out there that hasn't been patched? Do we really want to use this library then? Security library and frameworks and secure coding guidelines, right? As you develop your organization around this API security testing program, you want to think about standards and you want to think about guidelines. You know, we'll talk about that also, about the foundation of a security program is our policies and standards and building up from there. If you have people who are experienced in security or someone who knows, hey, you know, we need to be able to create a policy that does such and such, and we'll talk about that with externally versus internally facing APIs. You want to make sure that's clear and understood from the very beginning, that your standards and policies are such that people understand, okay, we can do this and we can't do this, as best you can, okay? Then moving further from that is the testing phase, where our organization will do things when the code is deployed to QA or even production sometimes, mostly QA. We're going to have our dynamic scanning, our dynamic assessments, meaning it's our team or an external team using tools, manual techniques, kind of an ethical hack light on the application to see what's going on out there at that time. That's in your testing phase. Okay, you can even go a step further and have a full-blown pen test on your APIs. Highly recommended at some point. You may not want to do it right off the bat, but when that time is right, you definitely want to have that to see how resilient your security is up to that point. Okay, and then out in production, right? Once everything goes to production, everything's cool, right? Everything's good, nothing's going to happen, right? Well, we know things happen. We know things are discovered even after the fact. And you need to be able to pivot. And what we're like the gentleman before us, we're continually monitoring our perimeter, always looking for something that may have been missed. Web app, our WAFs are up and running, automated bot defense. These are all things that an organization should have, you know, on top of an API security strategy for an overall security strategy. Now the next thing is, if you see API security strategy, this is my kind of selling point, right? For those of us who are trying to give API security testing its proper due, I say, hey, folks, it's the one that bridges the gap between development and testing. It's that one area, because you've got developers who can use tools to test their APIs. You've got QA testers who can use tools to test those APIs, and you can also have your pen testers and dynamic scanners. So to me, it really bridges the gap. And that's where I see it fitting in to the SDLC. And as you can see at the top, the cost to fix. For some of you, that might be the most important thing that you see here today in that slide, is that the farther you go out to the right of that slide, the more expensive it's going to be to fix it. It's not impossible, right? You can do it. But you can see that how the arrows go back to the left, it kind of circles back around. So that slide we saw earlier of the SDLC going like this is that same slide, only broken out in a far more detailed way. Okay, there we go. All right, so API security testing in action, right? Again, giving it we're going to talk about a case study today, giving it the respect it deserves, right? Profiling the value, so to our customers by ensuring standards and protocols are done. So what we've done between global security at Aetna and our digital assurance area is that we work together to build an API security strategy with different roles for different groups, okay? Criteria for security testing at API. The functional testing will be done by QA, by our QA security team, and the digital assurance will perform the vulnerability scans are done on APIs. The thing is the global security team does not have all day to test every single API. So this is one of the things you want to do, is you want to put the power back in the hands of your developers and your QA testers for security testing. If you have a security testing team at your organization, they're probably going to be busy with other things. They're not going to have time, a lot of time, to actually test every single API that comes out. You want this stuff being done, as we saw on that slide earlier on in the phase. You don't want to call the local ethical hacking team or the dynamic scanning team in your organization to fix this. You want your developers to take ownership of that with consultation with your security team. Mobile and web are the same. Okay, static analysis, we talked about that earlier. All teams, whether it be web, mobile, what have you, they have to perform static analysis. Static analysis is something, again, when your hands are on the keyboard and you're scanning your code, that's what you have to make sure that a minimum that has to be done. Any defect that is discovered during static analysis should be treated like any other bug, and just track that way. Because if people say, hey, I got a cross-site scripting vulnerability that I've discovered in my code, how do I fix it? How do I manage it? Treat it like any other bug, okay? And the same with web, okay? We've just recently made it clear for everybody with our externally facing API security policy, right? Again, we've got external and internal APIs. So I'll read it. As a method to allow access to common services, Aetna exposes both REST and SOAP APIs, not uncommon, to the internet in order to address business requirements such as providing services that are consumed by mobile and web apps. However, any API, therefore, shall only be exposed to the internet via an architecturally approved standard mechanism and shall not be exposed directly from web servers. So this is just something that we had practiced, but we finally codified it and got it down for people to understand. So what this means is that, hey, you can build externally facing APIs, but they have to be built in accordance with all those other things we saw in the previous slides. There's a clear requirements analysis, standard base. There is a way we're going to deploy or build these APIs and have them externally facing. You're not just going to go off and do something on your own and then tell us afterwards that you need a security test. With our digital transformation team, again, we have a case study where we have a lot of really good stuff that we've pulled together. It took our global security team out of the more traditional web and mobile testing, and over the last year or so, we've been really working with them closely with our QA security testers, and now this digital transformation, digital assurance team, we are taking to the next level where our QA security testers who are part of that, they're doing all of the testing with our consultation. This is kind of getting this up to another level where we are putting this together for the long term. Our API security testing strategy, so there's some bullet points there, an end-to-end process for security testing. So we put together a document, we worked together, we had our developers and our security team working together. How does this make sense, right? An end-to-end security testing policy, then steps to perform with different tools. An activity log, this is very important to track the activities going on, epics, features, stories, and tasks. Testing overview, the need of why security is needed, just like we're talking about today. Some people come into it late and say, wow, why are we doing this whole API security testing policy? What's this whole program, what's it all about? And then when web services overview, the document that contains the basics of web services components and their protocols. So we put all this together. This is more of the paperwork part of it, but it leads to a 30, 60, 90-day kind of breakdown. So again, this might be something that you would want to implement with your organization. On the left-hand side, defining best practices, processes up here, training, tools, very important to get those things kind of out of the way. POCs, testing different things to find out what works for you. And that's done by the QA testing team. Global security provides any training if necessary, and licenses and what have you. Within 60 days, okay, we're taking it a step further. We've got the tools set up. We've established our defect management process, and we've established metrics for reporting. Very important to establish metrics. Where did you start? where have you gone to? So that's something that you don't want to overlook the value of metrics with all of this. You're starting out with nothing, but sooner or later, as you build these things, people are going to ask you, well, how are we doing? What do the numbers look like? You know, how many of this or that do we, I mean, how many APIs have we tested? How many people do we have testing APIs? And what's been discovered? What kind of findings? Or, you know, how many APIs are in the clear? So different data slices for different people depending on what you're looking at. The 90-day window, again, we have what we call a Security Maven program. Security Mavens are developers who are people who want to go at the next step and learn about security, who actually want to be trained in security. So if you have developers in your organization that are really that one person who's always asking questions about security, hey, can I take this training? Hey, can I, you know, can we talk about this? That might be the person, he or she, that you want to focus on and make them your security maven or your security expert. And they might be the perfect person with that, we talked about early on in the slides with the requirements analysis and then design, you know, and then the actual development of the code. That might be the person should be probably actually the person you're going to find that's going to do that for you. They're going to want to spend the extra hours putting in the time to perform that kind of security testing. Okay. And then lastly, we have some KPIs, key performance indicators that we talk about. And with our area, we right now we're tracking APIs tested by the ethical hacking team, the number of API security mavens onboarded. And so again, KPIs are very important, part of that metrics program. Whatever you decide to implement, you definitely want to make sure that you're tracking the types of metrics that is important to you.